Today we're going to talk about arithmetic sequence and to identify if a given sequence is arithmetic or not. And then we will also have examples on how to solve a particular nth term in the sequence. Our first item to be solved is to determine if the given nth term produces an arithmetic sequence, such as this and this one. And our second example is to determine a particular nth term, 20th and 75th term given a sequence. And our third example is on a problem like this. Given the third term and a 15th term, we're going to find common difference, first term, and a particular nth term in the sequence. So our first example is here, a sub n equals 7 plus 4n, and we are asked to produce the first 5 terms of the sequence. So that means we have to look for first, second, third, fourth, and fifth term of the sequence. This is our a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So to solve for the first term, we let n be 1. So for a sub n equals 7 plus 4n, we let n equals 1. So a sub 1 is equal to 7 plus 4 times 1. And 4 times 1 is of course 4, and 7 plus 4 is equal to 11. So that means our a sub 1 or first term is 11. Doing the same process, to solve for a sub 2, we let n be 2. So a sub n, using the same formula, our a sub 2 is 7 plus 4 times 2. So 7 plus 4 times 2 is 8, and 7 plus 8 is 15. A sub 2. So our a sub 2 is 15. To solve for the third term, we let n equals 3. Our fifth term is 27. Now, if you are going to observe our generated terms are 11, 15, 19, 23, and 27. Now, if the difference between the terms is constant, we just simply subtract second term by the first term. 15 minus 11, that's 4. And if 19 minus 15 is also 4, and 23 minus 19 is also 4, and 27 minus 23 is also 4, so that means the difference between the terms is common, and that common difference is equal to 4. Now, if the sequence has a common difference, and that sequence is arithmetic. Let's have our second example. Our nth term is expressed into 2 raised to n plus 1 plus 1, and we are asked to generate 5 terms. So 1, 2, 3, 4, 5. So this will be our first term, second term, third term, fourth term, and fifth term. Now to solve for our first term, so will be our solution. To solve for first term, let n be equal to 1. So I'm going to copy the expression 2 plus 1 plus 1. So let n be 1. So our first term is a sub 1, of course. Then replace n with 1 now. And 1 plus 1 is 2. And of course 2 squared, or equals 2 times 2. Multiply the 2 by itself. 2 times 3, that's equal to 4, and plus 1, our first term is equal to 5. So our first term is equal to 5. Proceed to the next term. To solve for a sub 2, we let n be 2. So using this expression, we are going to substitute n by 2. And directly change the n by 2 now, because we will let n be 2. So a sub 2 equals 2, then n let n be 2, so that becomes 2 plus 1. Then copy the plus 1. And then 2 plus 1 here becomes 3. So the 2 now is being raised to 3. So a sub 2, 2 times 2 times 2, 2 cubed, is equal to 8. Plus 1, our a sub 2 is actually equal to 9. Our a sub 2 is equal to 9. So our second term is 9. Now, if we are going to inspect our answers 5, 9, 17, 33, 65, if we are going to subtract 9 and 9 by 5, the difference is 4. So 17 minus 9, the difference is 8. 33 and 17, the difference is 16. And 65 minus 33, the difference is 32. So as you can see, our differences between the terms is not common, so therefore this is not an arithmetic sequence. So it's probably going to be another type of sequence. So this is our second problem. Given arithmetic sequence -18, -7, 4, 15. Find the 20th term, or a sub 20, and the 75th term, or the a sub 75. A sub 75. So that would mean that our first term is -18, our second term is -7, our a sub 3 is 4, and our a sub 4 is 15. So in order for us to solve for the 20th term and the 75th term, we still need to use the general formula for the arithmetic sequence, which is the a sub n equals a sub 1 plus n minus 1 times the d. So our a sub n is our a sub 20 and the a sub 85th term to be solved. We have our first term, which is negative 18. Our n is the particular nth term to be solved, and our only problem is we don't have the d yet, so we need to identify what is our d. Now the common difference d can be determined by subtracting any two consecutive terms in the sequence. So I can choose a sub 4 minus a sub 3. That's gonna be 15 minus 4, and d is equal to 11. Or I can choose a sub 3 minus a sub 2, a sub 3 minus a sub 2. So that's gonna be 4 minus negative 7, and it's gonna be 4 plus 7, so d is equal to 11. So any terms you choose, two consecutive terms in the sequence, subtract them, there will be only one answer, since this is an arithmetic sequence, and our d is 11 in this case. So to solve for the first term, which is a sub 20, our first term is negative 18. Our n is of course the 20th term to be solved, and our d is equal to 11. 20 minus 1 is of course 19. 19 times 11, that's 209. And 209 minus 18 is equal to 191. That is our 20th term. Now to solve for the 75th term, we use the same process. Now we let our n here be 75. So our first term is still negative 18, plus our n here is 75 minus 1 times the difference, which is 11. And 74 times 11. 74 times 11 is 814. And 814 minus 18 is 796. So there you go, our 75th term is 796. Now what if the problem is this? Now our arithmetic sequence itself is not given, only a few details of the sequence, such as this. The third sequence of the arithmetic sequence is given, which is 22, and the 15th term is 130, and we are asked to find the common difference d, the first term, and the 31st term of the sequence. Now basically, if we're going to visualize our sequence, there are two terms before our 22, because our 22 is the third term. And there are terms between after that, and our 15th term is 130. Our 15th term is 130, so this is our 15th term. And basically we are asked to solve the d, our first term, which is right here, and our 31st term, which is somewhere here. So for us to be able to do that, we need to solve for d first. So in order for us to solve that, we need to assume that our 22 is our first term. So for us to be able to do that, we take 22 as our first term. So basically our a sub 3, which is the original position of the 22, so by just looking at it, a sub 3 becomes a sub 1 by subtracting 2. So I'm gonna do the same with 130 here, a sub 15 minus 2, and the position of the 130 in the new sequence is a sub 13. So basically we assume 22 as first term. So as you can see, our a sub 3 becomes a sub 1, so that's subtracting 2. And our a sub 15 here, simply subtract 2 also, and the new position of the 130 is a sub 13. So From this, we can now determine our D by using the general formula. A sub n equals a sub 1 plus n minus 1 D. Now, using our 130 as the 13th term, 130, and our first term here is 22, and of course our n here is 13 minus 1. We can now solve our D. So that's 130 equals 22 plus 13 minus 1 is of course 12D, and then 130 minus 22, 130 minus 22 is 108, and we need to divide both sides by 12 for us to be able to solve the D. Our D is actually equal to 9. Now, our D is already determined. Our D, so 12D divided 12 is D, and 108 divided 12 is 9. So our common difference is 9. So now we have the D, which is equal to 9, and using the D, using the generated D, we can now determine what is our first term. So we can just basically subtract the third term here by 9 to generate the second term and also the first term. The second term and the first term. So 22 minus 9 is 13, and then 13 minus 9, and 13 minus 9 is 4, and that is now our first term. Our a sub 1 is equal to 4. The next is, this is our third unknown. We need to find the a sub 31, or the first term, and in this case, since we now have the a sub 1 and the common difference D, we can now use the original sequence to solve for the 31st term. So the first term is of course 4, and of course the n there is 31 minus 1, and our D is already determined, which is 9. So our 31st term is 30 times 9. 30 times 9 is 270, and 270 plus 4 is 274. So this is our 31st term of the sequence. That's all about for arithmetic sequence for today. If you have comments and questions, feel free to give comments.